Okay, so I'm going to talk to you a little bit about the cyber-physical systems in the cloud era. You have heard already from the presentations from Dr. Riemenschneider and Professor Colombo, and also the previous one from Otto Karumaki about how the cyber-physical systems are increasing their prevalence also in the shop floor, and how these are equipped with new capabilities, and now we can attach them to the cloud. So we're going to approach this domain of how cyber-physical systems and the cloud can bring us some benefits about the future manufacturing. Coming from a company that specializes on the enterprise applications, we have to see what is the motivation of using this integration in manufacturing. And if you look, solutions that are developed follow or try to follow problem-solving areas, and some examples are streamlining of manufacturing processes for the whole life cycle, from the delivery, from the design to delivery, syncing of internal production operations with customer demand, provision of role-specific information to the staff that works on the shop floor, for instance, tracking material and products across the value chain, facilitating the handover between development and manufacturing, establishing safety measures for health, environment, etc., and managing the changes that come to product manufacturing. So all of these are kind of key guidelines when you try to develop new products or solutions there. And now we will try to see how we can approach these with the new tools, let's say, that we have, which is the cyber-physical systems and also the cloud. Trying to do these things basically means that we have to depend on the collaboration, not only at different layers, inside the different layers, but in a cross-layer way. So as you can see here, we have different things. We have devices in the shop floor that produce or consume information. These now can be represented or connected to services, and then they attach to what we call Internet of Services. And there it could be devices, it could be systems, it could be functionalities. And all of these services are attached to the Internet of Business Processes. So each one of these services is part of a business process, part of a business application, the logic that is getting executed there. But of course, the ultimate, let's say, addressee on the top is the people that have to collaborate with each other. We have to enable this collaboration, and we have to enable them to be able to get information from the bottom of the infrastructure and the different layers up, to be able to understand and analyze this information, to take decisions, business relevant decisions, and then once these are taken, to be able to enforce these decisions on the infrastructure itself. So this is a typical, let's say, rule how things are getting monitored, business decision is taken, and then it's applied. And we will try to see now how cyber-physical systems have a significant impact here, especially with the new capabilities that they bring, and how the cloud will change that. Let me introduce you now to a little bit of a research concept to give you a vision of how this collaboration is going to be done and how these new tools come into play. So I hope this can be started. Which, okay, maybe some sound. Okay, maybe I could explain what is happening there, but I think it will lose the key message of how everything gets integrated. Okay, so maybe we can skip that. So the key idea here was that people are on the move, the devices are also mobile, the information has to be available anywhere, anytime, and that now we are moving towards a new concept where the integration is not done based on the data that its device delivers, but based on the intelligence and information delivered by smart systems at different levels. And all of it, devices, applications, infrastructure, all of it can be hosted on the cloud and enable this seamless interaction between the different groups, between the different stakeholders that are not only on the factory. Again, it could be on multiple factories, it could be even outside the factory, because the factory of the future has to interact with many different stakeholders that belong to different domains. It's a pity that you could not, maybe we can try it later if it works, but yeah, I would skip it now. And
always connected, always collaborating. This means humans and machines complement each other because technology follows human needs, seeing and changing the world the way we do. The business web is part of creating the next radical change, the real mobile business cloud. And the answer to the question, how do we simplify things for our customers so that their business runs better? The business web shows us the way business will change. Join us and find out how.
Well, at least we got the last part of the of the message. But okay, let's go a little bit more into details. I think this slide depicts very well what are the next steps for the next industrial revolution. This comes from the DFKE in Germany, and we have seen that in the first industrial revolution we have been using mechanical production facilities, then we were using in the second industrial revolution electrical power, then we moved slowly towards electronics and IT, and now we are really at the beginning of the fourth industrial revolution, which is basically the introduction of cyber-physical systems. And not only the introduction of them, but what you can actually do with it, how they will enable or empower the new processes and the new paradigms and the new applications, and how all of this will come together. So the first step would be the massive introduction of them, but the follow-up steps would be, what can we do that? What's the things that are coming up? And if you see here, you see that the complexity also increases as we move along these steps. And complexity is a key aspect that needs to be tackled in the future. To make that a little bit more explicit, so on your left side, you can see a plane from the beginning of the previous century. And basically, by monitoring 3 to 5 indicators, you could actually fly the plane. If you move to a modern plane today, as you can see it on the right side, this is impossible. There are thousands of monitors that need to be considered, and all of these get aggregated in complex and generate complex events that need to be acknowledged by the pilot, and then by tweaking some of them, these high-level key performance indicators, then he is able to fly the plane. The same thing is for the future businesses and the future factories. We will need to harness the power coming from these millions of cyber-physical systems that is there, understand the data that they deliver, mass up the data, process it, take business decisions based on high-level KPIs, and by tweaking them, it should be possible to apply multiple changes that, we don't have the real view on that, but these get cascaded and applied to the infrastructure and enable the factory to perform in the best possible way. Now, when you try now to use the cyber-physical systems, and you have to consider what are the latest trends that are happening there, because things change at a very rapid form. First of all, we have seen the last decade the prevalence of internet technologies, IP technologies, web services coming into the factory and increasing the pace at which applications are developed. We have seen from the previous presentations also SOA-ready devices and systems, devices that can host intelligence, can host web services, can integrate themselves with their surrounding ecosystem, and these are increasing. And these devices, some years ago, we were speaking, these devices are very resource constrained. They have not much memory, not much computational power, and this is rapidly changing. We have today multi-core mobile network embedded systems that can host multiple applications, multiple graphical user interfaces. Some of them have increased GPU power, which basically means that you can actually do numerical analysis on these previously constrained devices. We also see the trend of virtualization and cloud computing, basically implying that resources are virtualized and stretchable. You can have unlimited resources for a specific task, and this gives us new capabilities. We also saw from some presentation yesterday 3D computing, printing, and on-site and micro-manufacturing. So all of these provide us new tools or new capabilities when we try to tackle this area. We see also bidirectional integration with business systems, right? Up to some years ago, we were only interested in monitoring what is happening on the infrastructure and then taking some decision. But now, devices, cyber-physical systems on the infrastructure itself can take information that is generated on other layers, higher layers, or distant functionalities and integrate them into their own, to increase their own performance, to increase their own capabilities, etc. high-performance analytics for asset management and reporting are key functionalities that now can be provided on the cloud because of the resources that we have there, and then they can be further attached or communicated to the devices and to the other systems. And collaboration between the different stakeholders is the key here. But the ultimate goal is to use all of these in order to create highly flexible shop floors that can accommodate agile enterprises. The enterprises of today change according to different economic rules, if you want, and it has to be possible that the factory also adjusts and delivers the best according to these rules. Just to give you an example now, traditional business processes were performing as you can see it on the left side, so it would monitor the devices, get some values, and then integrate that and take some decisions. But now we move towards scalable distributed business processes, where part of the logic can be executed not only at the enterprise system, but can be executed on the network, on the cloud if you want, or even on the device itself. And then we go towards what Dr. Riemenschneider said, we move the computation to the point of action, because that's probably the best way to have it there. And for whatever requires a global knowledge, this can still be done on the cloud, and we don't have to depend or push all the data to the end or the backend system. Now, all of this brings us to this cloud of things. As you can see on the left side, what we have today is the different devices. It's a hierarchical structure. They connect to a gateway or a SCADA or a DCS system, for instance, and to an MES, and then deliver the data to the backend systems. But on the right side, we will see that we have this movement towards functionality-based integration. A cyber-physical system is composed of a cyber part and a physical part. The physical part may reside within a specific place within the factory, but the cyber part can be distributed. The cyber part can be on the device itself, can be solely on the cloud, or can be divided between the two. Part of it on the device, part of it on the cloud. And by being able to attach to the devices or the functionalities on the cloud, then you have truly the connection between the cyber-physical systems and the cloud. And taking into advantage all the capabilities that are offered there, you can see that now you can have interaction not only in a peer-to-peer way, the M2M interaction, not only in a peer-to-peer way in the local, but also you can have it between cyber-physical systems that reside either on the same space or are distributed, and then they can be assisted with the cloud to interact with each other, something that might have been impossible before based on different protocols, different understandings of semantics, etc. And they can all harness stuff like management or like high-performance analytics, complex event processing, prediction services, knowledge management, decision support. All of these key functionalities can now be tapped into as they reside on the cloud. So even if the devices do not have enough resources to support these kind of functionalities, it doesn't really matter, because now they can connect via service-oriented architectures and web services, for instance, to the cloud, can take advantage of the resources that are there, and can enhance their own operations and their own interactions based on the information that they have from the cloud. You have seen this slide before. I'm going to say just a few words on this is the real world, as it was shown by Professor Colombo before. This is the real world based on the ISO 95, and what we are moving towards is an information-based interaction. So functionalities that exist in different levels here, part of these functionalities that make sense, could be represented as services in the cloud, and then we can very easily create new applications that tap into these functionalities and can be rapidly created. So the application of the future is not a monolithic application where you control all the layers. It is a mass-up application, control of different functionalities that may decide or reside in different layers, and then can be developed very rapidly. And it could be also services that tap into these services and create another complex service that can again be used for other services or for other applications. So again, we are moving towards an information-based integration that can coexist, of course, with existing infrastructures. Now, all of these are creating a lot of challenges, and you can see here some of them. So, for instance, management is one key challenge, security, managing the trust, how to do real-time analytics, business decisions, how to develop scalability and resilient systems, how to enhance this collaboration, and generally how to harness the benefits of these real-world applications. All of these are points that will need to be tackled in the next years and are not easy to do so. So, thanks a lot, and I will actually leave you with this slide, which has the challenges for the future. Thank you.
Thank you so much. Any questions? Yes. Oh, several.
Hello, good morning. That is a question related to, typically when the software, well, I am not an expert, no, but I can visualize that typically when the software has divided by segment, the business model is quite clear. So there are different suppliers at each layer. With the new paradigm, everything is mixed, so that poses a problem, apparently, in terms of business model. So how do you think that is going to be solved in the future?
So you should see that as a complementary thing. We don't speak about replacing what you saw on the left side. So this still exists. We speak about how can we deliver new applications in a more rapid way. And then you tap into features of these different levels. We don't speak about destroying that or replacing that. So it's only taking the features that we need for a specific application and might be assigned on different levels, and then creating an application that takes advantage of that.
So you think that the same business model, that existing one, is going to be maintained at the future?
I say that more, let's say, models can be developed that are compliant or complementary to the existing ones.
Certainly you create more functionality, and the question is who generates an added value based on the new functionality, through the other systems that exist. There was another question over here. After you.
Thank you. Marco Garetti, Politecnico Milano. The structure you present is very, very flexible, very challenging, but I think that a lot of problems can be solved regarding how to express knowledge, because all functions that should be implemented, but be implemented with this very flexible structure depends on the knowledge on the process, for example, or on the business process. So I think that ontologies or something like this will have an important role in this. What do you think?
Yeah, definitely. Probably it was not, I had it as KM, knowledge management, also in the cloud, which should be integrated there, but it was not, if you look at the slides, it's KM, but definitely it's one of the key parts that has to be understood, because it's going to be task-specific, as you said, and the expertise of the specific process needs to be integrated, and this is also something that poses a big challenge, because especially if you want to apply common tools in different domains, where you have different ontologies, etc. But this has been a problem for many years now, how to understand and how to build the right ontologies, and still a challenge.
I have one question. I used to work in a power station, and there we were not willing to put any part of the factory on the internet. Although we were asked by the company that produced the SCADA system and they wanted to be on the line, we told them we will put it on the line only when you want it, only for 1 or 2 hours, and then we will remove it. Do you think this will change?
Well, let's say that the existing model of having, let's say, an air gap in between does not work anymore, and if you look what happened with the Stuxnet, it's exactly that. The whole factory was disconnected, there was no internet connection at all. Still, the Stuxnet virus was introduced by means of USB keys and propagating through the internal systems. So no connection to the internet is not a guarantee for anything. And it will have to be shown, security is definitely a challenge, trust is another challenge. It will have to be shown what are the benefits of doing or putting some of the parts of the infrastructure on the internet, making automatic updates, or we don't necessarily speak that everything has to be connected on the internet, right? So the cloud presented here does not necessarily mean this is a public cloud. It could be an internal cloud and a private cloud. Still, the same concepts that you have seen here today apply and can be controlled by one entity. So the first one is not a guarantee, but when we speak about the cloud, not internet should not be coming to the mind directly. Internet technologies, yes, but not necessarily the public internet.